Let's take a look at this. John runs at different speeds as part of his training program. The graph shows his target heart rate at different times during his workout. On which interval is the target heart rate strictly increasing, then strictly decreasing? So this is the heart rate, this is the time.
Yeah.
So must be, you need to find the interval that is strictly increasing and then decreasing.
Yeah.
I mean, that's pretty straightforward, right?
Yes.
This is increasing and then stop, and then, I mean, increasing and then steady and then decreasing.
Yeah.
Increasing, then decreasing, right? So it's
Yes.
40 to 60.
40, 60. Yeah.
I would go for that. That's right.
Yeah.
Now, if we move on to the second question here. So this is also something that we have done before. So y equals kx, k is constant, and y is 24 when x is 6. What's the value of y when x is equal to 5?
So
let me give you some time for it. So we know that y is 24, so plug in 24 there. We don't know what k is. 6 there, x is 6, then k is equal to 4, isn't it?
yeah.
So 24 divided by 6 is 4. So therefore y equals to 4x, true?
Yes.
So plug in 5 there, then 4 times 5 is 20.
Yeah.
So the answer is 20. Well done. Let's have a look at this one here. So there are two parallel lines, and those are two sets of parallel lines there. Okay, so in the figure above, line L and M are parallel, and S and T are parallel. If the measure of angle 1 is 35, what is the measure of angle 2? So I'll give you some time for it. Yeah, so the reason for this is pretty obvious. This angle is corresponding angle with this one, right?
Yes.
This angle is vertically opposite angle to this one.
Yes.
And they're the same. Corresponding angle are the same. There's something called alternating angle, which is this angle here and this angle here are alternate angles.
Yes.
Anyway, so this is the same as this, and this is the same as this. That's corresponding. Yeah. So this must be 145.
Yes.
Because that's 35. They must add up to 180. True?
Yes.
So that one is the answer. Okay. Yep, question 4. So 16 plus 4x is 10 more than 14. What is the value of 8x? I'll give you some time for it. Did you get 80?
Yes.
Okay, so 16 plus 4x is 14 more than 10 more than 14, which is 24, right?
Yes.
So all that's saying is that this is 24. So you get 4x equals to 8 there.
Yes.
Which means you simply times it by 2 and times it by 2. Then you get 8x, which is 16. So I think the answer is 16.
Oh, wait. Oh, okay, I did this wrong. Wait.
So what was your way?
So I did, I thought I solved for x and then multiplied that by 8, but I must have got the wrong x value.
Okay. So was this the same answer then?
Yeah, so that was this.
Okay, so if you move the 16 there, then you get 8. So if you divide by 4, then you get x is equal to 2.
Oh, okay. Right, yeah.
So 2 times by 8 is 16, right? So I'm not sure you got 80 there. Anyway, moving on to the next question. So this one is about statistics. So have a look. Question 5 there, section 4. Yeah, so which of the following graphs best shows a strong negative association between D and T? So it's a very basic question, you know.
D.
Must be D, that's right. So as D grows, T goes down.
Yeah.
That's the negative correlation, negative association. I would say this one's weak negative correlation, association. This is no correlation, really. Pretty flat there. And that's a strong positive association.
Yeah.
Okay, and we're going to talk about number 6 now. Let's have to go with this one here. So 1 decagram is 10 grams. 1,000 milligram is 1 gram. So a hospital stores one type of medicine in 2 decagram containers. Based on the information given in the boxes above, how many 1 milligram doses are there in 1 2 decagram container?
Okay.
So it's a pretty confusing one, right?
A little.
So I'll give you some time for it. One way of thinking about it is you convert the 2 decagram into milligram. Okay.
Yeah. That's
And
so.
you divide that by 1 milligram because each dose is 1 milligram, right?
Yeah.
So you figure out how many milligrams are there in 2 decagram container.
Yes.
Let's have a look. So 2 decagram, you times that by 10, then you get, because there's 10 grams there, right?
Yeah.
In 1 decagram. So this is 20 grams, true?
Yes.
And in 1 gram, there are 1,000 milligrams. So 20 gram times it by 1,000, then you get 20,000 milligram.
Yeah.
That gives you, of course, how many 1 milligrams are there? 20,000. All right?
Yeah.
So it's just a good practice if you instead of doing like this, sometimes, so for some identity like this one, so this is a unit conversion, you can write it like this: 1 decagram, 10 gram. Or you can write it as 10 gram, 1 decagram. You can write this one here as 1,000 milligram over 1 gram, or you can write it as 1 gram over 1,000 milligrams. So I'll show you how this is useful, okay? Let's say 1 Australian dollar is equal to 0.7 US dollar, okay? Now, I've got 1,750 Australian dollar.
Yeah.
What I can do is I can simply multiply. Of course, some people can just do it. You just multiply by 0.7.
Yeah.
But sometimes you have to divide by 0.7 if you've got US dollar,
Yes.
So how do we know when to divide by 0.7 and when to multiply by 0.7? It's very simple. When you have some unit identity like this, you construct this fraction. Either 1 AUD, 0.7 US dollar, or 0.7 US dollar on top, and then 1 AUD on the bottom, okay?
Yeah.
If you got AUD and you would convert that into US dollar, all you have to do is times it by one of this. And the answer is you got to multiply by this one. Why?
Oh, okay.
Because you want to cancel the Australian dollar, then you get US dollar, right?
Yeah.
So that's why you have to multiply by 0.7. So if it's ever confusing to you, you can use this fact and do the conversion.
Yeah. Okay.
Now, if you've got like 300 US dollar, you want to convert that into Australian dollar, then you have to multiply by 1 Australian dollar is 0.7 US dollar, right?
Yeah.
Then in this case, of course, US dollar cancels out. You got to divide 300 by 0.7.
Yeah.
So in a similar way, you can also convert like 100 kilometers per hour. You know how fast 100 kilometers per hour is, right?
Yeah.
Yeah, you used to Australian system, true?
Yeah. Yes.
So how many is that in miles per hour, Or how much is that in meters per second? Let's do this one, okay?
Okay.
So we know that, so you need to multiply this by this identity. I need to cancel the kilometer, right?
Yes.
So I put 1 kilometer. I know that 1 kilometer is 1,000 meters, right?
Yes.
Then the kilometer will cancel. And I want to cancel the hour and make it into seconds. So I need to put hour and second there. But I know the connection between hour and minute.
Okay.
That's a lot easier, right? 1 hour is 60 minutes, right?
Yes.
So then the hour and hour cancels out. And then I need to cancel the minute and turn it into seconds. So I need to have a minute here and seconds here.
Yes.
I know that 1 minute is equal to 60 seconds. The minute cancels out. So you're left with meters, seconds.
Okay.
Minutes on top. Meters on top and seconds on the bottom. So I've got to. I've got 100 kilometers per hour. I need to multiply by 1,000, divided by 60, divided by 60.
Yeah. Okay.
So that's what you have to do, which is the same thing as. Simply, this is the same thing as, multiplying by 1,000 over 3,600, because 60 times over 60 is 3,600.
Yeah.
So this is the same thing as 1 over 3.6.
Okay.
So that's why we divide by 3.6.
Yeah.
So as a rule of thumb, you can just memorize this as if you've got kilometers per hour, turning into meters per second, you just divide
Yeah.
by 3.6. But the calculation is done this way. The proof is here.
Yes.
So it's about 28 meters per second. So if you're traveling at 100 kilometers per hour, you're actually going 28 meters in a second.
Okay.
That's pretty fast, isn't it?
Yeah.
So yeah, this could have been done this way as well. So if you have 2 decagram, so that you've got 2 decagram, multiply that by decagram gram. I know that 1 decagram is 10 gram, right?
Mm-hmm.
Then the gram cancels out. I need to get milligram and cancel the gram, true?
Yes.
So I know that 1 gram is 1,000. True?
Yes.
So that's why it's times by 10 and times by 1,000. Then you get the milligram. So they get 20,000 milligram. Understand?
Yes.
Okay. So rooftop solar panel installation in 5 cities. So this. There are 5 cities there. Number of rooftops with solar panel installations in 5 cities is shown in the graph above. If the total number of installation is 27,500, what is an appropriate label for the vertical axis of the graph? Over here. So this is about 9, 5, 6, 4, 3.5.
Mm-hmm.
But if you add them all up, it must become 27.5, okay?
Yes.
So if I just do the math, 9 plus 5 plus 6 plus 4 plus 3.5, I think that's 27.5, isn't it?
Yes.
Because that's 10 here. That's 14 there. So it's 24 plus 3.5 is 27.5.
Yeah.
But it's must be, so should this 9 here represent 9,000 or 90,000 or 900 or what? I don't think it's going to be tens, right?
No.
That means this will be 90, 50, 60, but that's not going to be 27,500. So what's the answer?
Hundreds.
Then this will be 900.
Yes.
So is 900 plus 500 plus 600, 400, then this will be 350, right?
Yes.
Is that really equal to 27,500?
Oh no.
Don't think so, right?
That's 20. Yeah. That's
too low. Should
Yeah.
be thousands. 9,000.
Yeah.
5,000.
Yeah. Yeah. I see that now. Yeah.
Yeah. So easier way of doing this is I should multiply this by what to get 27,500? I've got 27.5, and look at the English here. This is 27. 27. How much is that?
27,500.
27,000, isn't it?
Yeah.
So I need to multiply by 1,000.
Yeah.
This one.
Right.
See?
Yeah.
So 27,500. This is 27.5.
Yeah.
Anyway, so you get the point, right?
Yes.
Let's try this one now. So for what value of n is this plus 1 equal to 0?
Yeah.
So for what value of n?
Wait, so is the bars mean absolute value?
Absolute value. So for example, if you have an absolute value of 3, the answer is 3. If you have absolute value of -3, the answer is 3. If you have absolute value of 0, you have 0. Okay? So whatever you put in there, it comes out positive or 0.
Yeah.
0, then it's 0. Okay?
Yeah.
Yeah, a lot of people think it's 0, but if you plug in 0 there, what happens is you get 0 minus 1 plus 1, but then this is a absolute value of -1, which is positive 1.
Yeah. So is it D?
It's actually D. That's
Yeah.
right. So there's no value because, think about this. If you have an absolute value of whatever plus 1, okay?
Yeah.
Think about this. This value here needs to be -1 in order for this to be 0. That's what it's asking, isn't it?
Yes.
But can this absolute value thing be negative at all?
Oh no. No.
It cannot be, right? It can
Yeah.
never be negative. There's no way this absolute sign be negative, so that's why there is no answer.
Okay.
Minimum value that this can be is 0.
Yeah.
Or positive. You know, positive number plus 1 is positive, you know?
Yeah.
And even 0 plus 1 is positive. So that's why there is no answer for this. So this one here is a straight line with a 1052, that point there, that's the y-intercept, and it's got gradient of 1.08, right?
Yeah.
So for example, if temperature is 1, then this will rise by just about 1.08. So this value would be 1053.8. This value here is 1052.
Yeah.
Okay, so it just rises by 1.08. That's the meaning of the gradient.
Yeah.
Anyway, so the A is the speed of sound, and T is the temperature. So as temperature goes up, speed of the sound increases.
Okay.
That's what this is telling us.
Yes.
And well, it's a very simple question. So what is the, if you want to rearrange this equation in terms of, so that you get time, which one of those is the correct expression? So it's a pretty simple one. So you can try that.
Yeah, that took a
So you
bit.
got T. So have a look. If I move 1052 to the other side, A minus, like that,
Yeah.
and you go 1.08 T, right?
Yeah.
And divide by T, then you get A 1052 divided by 1.08. That's T.
Yeah.
So that's this one here. Well done. Which of the following air temperatures will the speed of a sound wave be closest to 1,000 feet per second? So what that means is that A is 1,000.
Yeah.
And you want to figure out T.
Okay. So
The answer is -48, right?
yeah.
You can just plug that number in here, then you get the temperature, and you will find that that's equal to about -48 Fahrenheit.
Yeah.
Okay, maybe one more question, and then we can call it a day.
Sure.
All right. Okay, so which of the following numbers is not a solution to this inequality? So there are two ways of doing it. one way is you can just plug this number, plug these numbers into that and that.
Yeah.
And see if the inequality sign holds. But that's a little bit inefficient.
Mm-hmm.
So another way is, because if you don't rearrange this equation, you have to plug these values into this and this twice.
Yeah.
Once here and once here. But if you rearrange the equation, you can just plug it in once. All right?
Sorry, I just need to grab my laptop charger real quick.
Okay. So let's rearrange this equation. But for example, if you don't like to rearrange, then you can just plug it in here and plug it in here. So if I plug in -1 in here, then you get -3, -5, -4, -3, true?
Yeah.
Then you get -8 is greater than -7. So that doesn't work.
Yeah.
So that's not an answer. What I say is, which of the following is not a solution? So A would be the answer.
Yeah.
Okay, so we can check that straight away. If you plug in -2 there, -2 there, you get -6 minus 5, -8 minus 3, so that's -11. And this is -11, which is correct.
Yeah.
-11 is greater than or equal to -11.
Yes.
So that's still fine. Like that. But let's rearrange this equation. You need to know how to rearrange that. You know, if you know how to rearrange this, right?
Yeah.
Then, I mean, if you know how to rearrange this, then you know how to rearrange that, okay?
Yeah. Okay.
So if I move that over, then it's a 4x minus 3x. I'm going to move this one. I'm going to move this one, okay?
Yeah.
So it's 4x minus 3x. And if this one moves over, then it's positive 3. 3 minus 5, okay? So that's minus 2x. So that's like that, okay?
Yeah.
So if I rearrange this, you get the same thing. You're going to get something like this.
Yeah. Okay.
So x must be less than -2. So the answer is all of that is fine.
Yeah. Okay. Yeah,
Right?
I
Because
see.
x must be less than or equal to -2. So
Yeah.
that's fine, that's fine, that's fine, but this is not fine.
Yes.
So this is direct solving, whereas number 1 method is trial and error.
Yeah. Okay.
This is a direct solving. Okay?
Yeah.